This video shows how to assign finite values to divergent infinite series using advanced mathematical techniques like Ramanujan summation and zeta function regularization. These methods are crucial in modern physics, particularly in quantum field theory and string theory calculations. You'll learn to understand analytic continuation, apply regularization techniques, and see how seemingly impossible sums connect to physical reality. We'll build toward the famous result in 3 stages. First, the Grandi series 1 minus 1 plus 1 minus 1 and so on, assign the value 1/2 by Cesaro averaging. Then we use that to evaluate 1 minus 2 plus 3 minus 4 and so on, getting 1/4. Finally, a clever subtraction links our target series to that result, yielding -1/12. Let's work through it on the diagram. 1 plus 2 plus 3 plus 4, all the way to infinity. Every student knows this diverges. Yet Ramanujan wrote that this sum equals -1/12, and string theorists use this result every day. This isn't ordinary summation. The trick is to assign a value through regularization, extending a function beyond where the sum converges. It sounds like cheating, but it's rigorous and physically meaningful. Goal: show that the regularized value of 1 plus 2 plus 3 plus ... is -1/12. Step 1. We start with the simplest divergent series, Grandi series, 1 minus 1 plus 1 minus 1, and so on. Let S1 be 1 minus 1 plus 1 minus 1, repeating forever. If we subtract S1 from 1, the right side becomes 1 minus 1 plus 1 minus 1, which is S1 again. So ENS minus S1 equals S1. Solving gives S1 equals 1/2. This matches the Cesaro average of the partial sums. Now we use S1 to evaluate a slightly more complex series. Step 2. Now consider the alternating series 1 minus 2 plus 3 minus 4, and so on. Let S2 be 1 minus 2 plus 3 minus 4, continuing forever. Write 2 copies of S2. Shift the second copy 1 position to the right and adding term by term. 1. Then -2 plus 1, then 3 minus 2, then -4 plus 3. The result is exactly S1, which is 1/2, so S2 equals 1/4. Now comes the key move, linking S2 to our target series S. Step 3. Now we connect everything to our target series S equals 1 plus 2 plus 3 plus 4, and so on. Subtract S2 from S, term by term. The odd position terms cancel. We're left with 4 plus 8 plus 12, and so on. Factor out 4. This is 4 times 1 plus 2 plus 3, which is 4s. Substitute S2 equals 1/4. Rearranging, -3s equals 1/4. Therefore, s equals -1/12. This is the zeta function evaluated at -1. Whenever you encounter a divergent series that needs a finite value, especially in physics, look for regularization techniques like zeta function continuation. The strategy is to build from simpler divergent series, Grandi then alternating, using shift and subtract to create self-referencing equations. Each series bootstraps the next. Zeta of -1 equals -1/12. Not a sum in the ordinary sense, but a value that the analytic structure of the zeta function uniquely assigns. It appears in string theory's critical dimension calculation and in Casimir effect computations.